Hello and welcome to this video out of my Networking Basics series where I talked about the IP protocol today. I'm Wolfgang Dremmel and I run the DKIX Academy. If you're interested in more videos talking about networking basics or BGP Border Gateway Protocol or any other content from DKIX, just head over to the DKIX website and go to the Academy subsection. All right, let's get started with the presentation. IP protocol. This is part of a series of presentations. When I started this writing about an introduction seminar or course about all things internet. And I talked about Ethernet, I talked about the networks in general, and I will talk about the higher protocol layers as well. But today I'm talking about the internet protocol called IP. And before we can talk about IP, what is a protocol? Well, a protocol is kind of a common language. So if you want to communicate with someone, you need to speak a common language, otherwise you will not understand each other. And the same is true talking about network devices, about computers, about anything connected to a network. They need to speak a common language, a common protocol to be able to communicate. And it's not just one protocol. If you have watched the previous videos, you know that there is also Ethernet and there is also the so-called physical layer. They all build the protocol stack. Multiple protocols building upon each other. We start very low at the physical layer. And here we have electrical cables, we have fibers, we have light pulses. And this makes the physical part of the communication. One layer above, we have the so-called link layer. And in the link layer, data units are called frames. And the purpose of the link layer is to provide a hop-to-hop and node-to-node data transfer. So from my laptop here to my Fritzbox downstairs. And an example of protocols on the link layer is, of course, Ethernet, and there is a separate video about that. Talking about Ethernet, I introduced also the frame structure of Ethernet. And there are two important fields when we come to the relationship between the IP protocol and the Ethernet protocol. And one of them is EtherType, which contains a number which tells the layer above what is contained in the payload. And the other one, of course, is the payload. The payload contains an IP packet. The payload of Ethernet in the internet context usually is simply IP. And this is data inside data. It's called encapsulation. And you can just imagine that just like the Russian dolls, there is one smaller always inside the other one. And here in this case, we have an IP packet inside an Ethernet frame. And of course, the IP packet itself also contains other types of data. So with the IP layer, we are on layer 3. Data units here are called packets, and the purpose of layer 3 is to provide end-to-end source to destination transport. So from here to Australia, if you want to transfer data to Australia. And of course, what do we need in the internet layer? We need addresses. We need addresses for the systems to communicate. And examples for protocols on the IP layer, you might say, oh yeah, it's IP, but actually there are two protocols in use nowadays. And the one is called IP version 4, and the other one is called IP version 6. And you might have heard of both of them. Let's start with IP version 4. How is an IP4 packet structured? And of course, we have a header and we have a payload. Let's have a look at the IP version 4 header, and let's explain some of the fields you can see here. It all starts with a version number, which is of course 4 in this case, and a length of the header. Also, we have the total length of the packet, and you might be surprised. I told you the payload of Ethernet is 1500 bytes, and the IP packet can be much larger. Well, first, the IP packet doesn't know that it is contained in an Ethernet frame. And also, you can basically split up one IP packet over multiple Ethernet frames. But that's called fragmentation, and we talk about that at another time. Another important field is the so-called time to live field. And this is a counter which tells you how many hops an IP packet can travel. And once this counter hits 0, the IP packet is discarded. This prevents from IP packets circling forever the internet, kind of. Then we have a protocol field, and this is similar to the type field in the Ethernet header. It tells the system what kind of payload this IP packet contains. And then, of course, we have the source and destination IPv4 addresses. IP version 4 addresses are 32 bits in length, and that's important to keep in mind. Also, we have a so-called optional field, which means optional that it might be there or not, which is a bit of a problem sometimes because this causes that the IP header has a variable length, which is bad if you want to process anything automatically in hardware very fast. IP version 6 has fixed that. So before I go to IP version 6, I am answering the obvious question: whatever happened to IP version 5? Well, there was never an IP version 5. The version number was reserved for a protocol called the Internet Stream Protocol. It never took off, but since the version number was used, they decided to use the next number when designing the new IP protocol, which then was called IP version 6. And yes, IP version 2 and 3 also did exist, as far as I know, only on paper, but the numbers were considered to be used. So in reality, we have IP version 4, the old protocol, and we have IP version 6, the protocol currently, hopefully, mainly in use soon. Let's have a look again at the header. The header in IP version 6 has a fixed size of 40 bytes, which makes processing way easier. Also, the header looks less complicated. We have at the beginning the version number, of course, and some flag fields and label fields. Also, we have the payload length only. Since the header has a fixed length of 40 bytes, there is no need anymore for a header length field. Then we have the so-called next header field. This replaces the protocol field, and it points to the next header, tells you what kind of next header we have. And it doesn't have to be payload. It can be also an extension header. IPv6 allows extending the header with optional additional headers. The hop limit replaces the time to live. Well, basically, it's just renaming. Time to live, there isn't a time in this field like in seconds or in minutes. It always was a hop count, so they just renamed it. And it is the same purpose. It starts at a value of 64, 128 or so. It counts down with each hop the packet travels, and once it hits 0, the packet is discarded. And the address field, this is the main difference people see between v4 and v6. The addresses are now 128 bits long. which gives you enough address space for a long, long time, hopefully. Talking about IP addresses, let's talk about IP version 4 first, because I guess you all are already familiar with them. IP version 4 addresses, well, you all have seen that perhaps. It's the common writing of IP addresses, 32 bits in length, numbers with dots in between that, and so on. Talking about classful addresses, you might perhaps have heard of class A, B, and C addresses. Please forget about that. There is no such thing anymore. There are no class addresses anymore, and this is since 1993. If you hear somebody talking about a class C address, tell him, well, it doesn't exist, and perhaps that person should retire. Good. All usable IP addresses are equal. And I will tell you more about this in another presentation. IPv4 addresses, as I said, are 32 bits in length. This means there are a high number of addresses. A part of it is not usable, so usable are about 3 billion addresses, and they have been all used up. They have been all handed out to internet providers and end users. The addresses are written as 4 decimal numbers separated by dots, and like I said, some of them are reserved and not usable. All usable addresses have been assigned. What's the solution? Use IPv6. And IPv6, some people tell that that's the new IP protocol. Well, it first has been published in 1995, so it's not that new anymore. Talking about IP version 6 addresses. Well, 128-bit in length. That means there are a gazillion, a really, really large number of possible addresses. Also, there are a lot of IP version 6 addresses available and usable. And the writing is a bit different. It's written as hexadecimal numbers, so 0 to 9 and then A to F. And they are separated by colons instead of dots. All these writings here mean the same. So a double colon means fill up with zeros. So all these 3 addresses here on the right-hand side, it's the same address actually. The double colons means filling up with 0. Also in IPv6, like in v4, some addresses are reserved and not usable. Let's talk about the IP protocol, about the history of the internet, the history of IP. How did it all start? Well, it started early in the 1960s. And to debunk a myth, well, the internet IP was never meant to survive a thermonuclear war. The internet was founded by the Defense Advanced Research Project Agency, the DARPA, so actually by the military, but the purpose was a different one. DARPA handed out grants to university to do research, and all these universities, they wanted to have expensive supercomputers. And they said, okay, no, you're building 1 or 2 supercomputers and you have to share them with the other universities. And if you want to share computer power, you need a network. And this was the idea of IP, of the internet, sharing computing resources. This was where it all came from. And let me give you a little bit of a timeline of the internet. In 1961, the concept of a packet switching network was written down. And in 1967, the so-called ARPANET was planned. ARPANET was the predecessor of the internet. In 1969, the first node came online, and the first RFC means request for command, and these are papers containing internet standards. The first RFC was published in 1969. In 1972, this network was first publicly demonstrated. And finally, in 1974, the term Internet was first used, and the protocol we are still using today, IP and also TCP, was described. But at these days, the ARPANET was still using a predecessor protocol called NCP, and in 1983, ARPANET switched over in one night from NCP to TCP/IP. Just imagine today somebody would switch off the internet to do a change and turn it off for a whole night. Impossible. But the internet was way, way smaller at this time. Why was the internet so successful? At the time it was invented, there were competing protocols. Do you remember DECnet or BitNet or OSI? Not really. All of the other protocols, they were either vendor proprietary or just theory. Vendor proprietary in this case means one manufacturer, one inventor holds the licenses for these protocols and charged, of course, license fees if you wanted to use it. The internet, not. The internet was always free to implement, free to use. Also, the IP protocols, because of their openness, they evolved way more quickly. All standards were and are publicly available. Everything was open and still is open. In 1969, the first request for comments was published, and it was memos, it was standards, and well, today RFCs still exist, and there is a process publishing them. Also, there is an open process making an internet standard. Everybody can participate. It's an open process and it's open. I think this was one of the main success factors of IP and the internet. Okay, conclusion. What do I want you to take you away from this video? The IP protocol takes care of end-to-end communication. There are two protocols on the IP layer. That's IP version 4 and IP version 6, and they coexist. They are both heavily used. IP packets, they have a header and a payload. And of course, IP version 4 and IP version 6 headers, they are different, but both have and contain source and destination IP addresses, where IP version 4 addresses are 32 bits long and IP version 6 addresses are 128 bits long. The payload can yet, of course, be another protocol. And well, that's it. Thank you for listening. The appendix of this presentation contains a number of useful links for further reading, so please download the PDF containing the slides and have a look at the end at the links section. That's it for today. Thanks for listening. Thanks for watching. I'm Wolfgang Trammel from the DKIX Academy. Bye-bye.